So let's have a look then. Let's have a look at the code. So these are the files that you have, that you download. The first few are just to set the initial conditions or the initial positions of the servos. And what I will say is I had to rename these. When you had the initial files, they had names like this. So 7-5 underscore adjust the servo to 90 degrees. When I tried to upload that directly onto my Arduino IDE, it didn't work. And I'm assuming it's because of this dash here, although it could have been that it was just too long. Whatever the problem was, it didn't work. So I renamed every one of these to take the dash out and make it slightly shorter, all those to still let me know what it is that it was doing. So that might be something that you need to do as well. Like I said, these first few are just about setting the initial positions of things. It's really these last few which are the kind of the meat of this project. So controlling the robot arm using a joystick, being able to set different locations and then loop back through them is the second one. Connecting to the robot arm from Wi-Fi is the third one. Connecting via a web page is the fourth one. And then the fifth one is Wi-Fi control, like in an app. Okay, so I'm going to walk you through these last ones, not the first few. So at the moment, I have this code open. This is the one that lets you control what the robot arm is doing with the joystick. Now, just in case you haven't seen code like this very often, I wanted to explain what we're seeing. If you do know about how to read Arduino code, feel free to skip forward. So at the top, we have the tutorial code and what it's doing. We then include the library for servos, otherwise we can't talk to the servos. We're defining the 4 servos, the ones that are at the shoulder, elbow, wrist, and the gripper. So they have their own names. We're then saying which servo pin they're connected to on the ESP32. And then these down here are the joystick pins. Now on the joystick, you have a right and a left button, and you can move those buttons along the x-axis, the y-axis, or pushing it for a B. So let's have a look then at what this would look like. Let's get down to robot arm projects, go to the joystick control, and here we have a picture of what this looks like. Okay, so the joystick has a right and a left, and then along it, it has the X direction, which goes from right to left, the Y, which goes up and down, and B is actually pushing the button in. So as we can see up here, if you're to the right side, or if you push the joystick to the right side, the X goes to 0. And if you push it all the way to the left side, it goes to 4095. Now, the computer program is essentially listening to see if there's any change in the X value, the Y value, or B being whether the button has been pressed. And if any of those things have changed, it then changes your robot arm accordingly. And here's an example of what the joystick does. Here's our left one. If we go from right to left, it makes the arm rotate. If we go up, down, it makes the shoulder go up and down. If we go to the right side, if we go up and down, it makes this elbow joint here move up and down. And if we go from left to right, it makes the servo open, it makes the gripper open and close. So if we walk back to the code, this is defining what each of the pins are for the joystick. Here we have the initial angles, which we've talked about a couple of times now. They're all originally going to be 90 degrees. And it's also going to set up the different pins so that we know which pin goes to which location on the joystick. It's going to write those initial conditions. So if it wasn't originally in 90 degrees, it will go to 90 degrees. And then this is the bulk of the time when it's listening. So it's continuously listening to see if anything is being put in to the joystick. And what I mean by that is, are any of the buttons moving or being pressed? If they are, it then calls different commands, which will change where these different servos are. For example, what the angle is of these. So what this is doing, if we do base control, is it's looking to see what the value is of the left X. So that's the X position on the left side of the joystick. If that number is bigger than 3000, what that means is you're pushing it towards the left. What it will do is it will look to see if that number is bigger than 3000, and if it is bigger than 3000, it will increase the angle until you get to 180. The reason 180 is chosen is because that's the extent of what the servo can do. If, on the other hand, you have moved the joystick towards the right to a small number, smaller than 20, it will then move the servo to the other direction until it gets to 0. Again, the servo can't go past 0. So the servo will move between 0 and 180 degrees depending on whether you've moved the joystick pin to the right or to the left. And it does this in very, very similar ways for the other commands as well. I'll show you those bits of code fairly quickly. Okay. And that's essentially what it's doing. It's not memorizing where anything is. It's just real-time action. If you push it one direction, it goes one direction. If you push it the other direction, it goes the other direction. Okay, so let's move on then to the next bit of code, which is this one. So the first step, as normal, is going to be to upload it onto our ESP32. So we check that the board is right and that the port is right, and it is. So we'll go ahead and click upload. And that can take a while. So while it's doing that, I will go through the code. So again, up here, we have an explanation of what the code is. We're including the library for the servo. We're defining what those 4 servos are, talking about what pin they're on, and defining the joysticks pins as well. So no different from the other code. Again, we're setting the initial angles to 90 degrees. But now we have a little bit more information about these numbers for the servos. Oh, here we go. So it's now uploading. It's writing it to the various bits, and then it will finish on the pin. What this means is it's now ready to listen to us. Okay, but going back to the code. So this is setting up the different pins, again, to let it know what pin number goes to which of the joysticks. And then the meat of our program in this loop, again, it's listening to see what it is we've asked it to do. So until we press something, it's just listening. Once it's listening, it then can control the different bits of the servo arm, and the extra one we have now is this attitude, which it's also going to be running. This base control is exactly the same as before. It just says as we change, in this case, the X position on the left side, it'll rotate the arm from the right to the left. Yeah. And this similarly is about moving the shoulder up and down. The forearm control is about moving the elbow up and down, and the claw control is opening and closing the gripper. The difference for this bit of code, which is different from when we had the joystick control from before, is this attitude now. This is letting us save the data and then later on look for it again. So it's saying if we've pressed the button, essentially, we're going to save the location that it's at. And we're saving the location of all 4 of those servos. Okay. So once we press the button, it saves the information. Now we can save it for up to 10 times. You can change this number if you want. You could make it save to 20 times or to 5 times, whatever number you want. But the code comes with 10 times. So it's going to listen for 10 different locations. And then once you press the other arm, it's going to cycle through those 10 different locations automatically. So the difference is with the joystick, it was listening to what we said and it immediately went to a position. Here, it's remembering those 10 sets of positions, and then it's going to loop through them. Okay, so it's then looping through them here, and that's the end of the file. This is a really interesting code if you want to do something like pick and place in manufacturing, because you can set 10 different locations, for example, to move something from one side of the robot arm to the other, which is something you could use in manufacturing.
Success.
Next, we're going to go to the code for connecting to Wi-Fi. we're going to go over the computer code that lets you check that your robot arm can listen in with the Wi-Fi from your router. So here's the code here. Now we have a different library that we need to connect to the Wi-Fi one. The reason we don't need the servo library here is that we're not actually using the servos in this code. We're just making sure that you can connect to the Wi-Fi. So the first bit of information, you need your SSID and your password. Now this is specific to you, whatever your router name is and whatever the password is for yours. You'll need to change this. If you don't, it won't work. What will happen is that your ESP32 will try to find the Wi-Fi. So it will try to see what the status is, and when it's not connected, it will just make a line of dashes. And once it does connect, it will say Wi-Fi connected. Okay, and it does this continuously, and this is all that this bit of code does. Okay, this bit of code goes one step further, and in addition to connecting to the Wi-Fi, it then lets you look at a web page. So now we have the library for Wi-Fi, but also another library for the web server, so you need to be sure that you've installed that library. You have your SSID and password again, same as you did before, but now we have a Wi-Fi server as well, and we've set it to the web port of 80. So once you have begun this code, it's going to try to connect to whatever your router is. If it doesn't connect, same as before, it will give you a line of dashes, and once it does connect, it will say Wi-Fi connected, then it will say server started. It'll give an IP address, and then you can use that information to open a web page to try to see whatever it is that you've sent. So in our case, we've created a website that's just going to say hello world. So you have the HTML tags at the top, and then you have whatever it is you want to send on the next line. Once it's done that, it then closes the connection. It waits for a tenth of a second, and we can begin. So this is taking quite a long time to upload, but you can see that it's working on it now. So I'll let you see what the web page looks like. Okay, it should be there now. So if we go to the serial monitor, the information. So we had the dots while it was connecting. Now it says Wi-Fi connected, the server started, and it gives us an IP address. If we now open a new website and then put in that IP address, it says there's a new client down here where we tried to get in. So as you can see, this doesn't always work, and in fact, frequently it didn't work for me, but I did get it to work sometimes, so I'll show you an example of it here. Moving on then to the last bit of code, that was the Wi-Fi control. So by now this code should be familiar to you. Now we have 3 libraries. We're including the Wi-Fi, the web server, and the servos. Again, you need to input your individual router's SSID and its password. It's then going to define these pins to set up each of the servos, to initially set everything to 90 degrees, and then it will set everything to 90 degrees. It will try to check whether the Wi-Fi has been connected, and if it has, it will tell you what the IP address is. It then initializes everything again to 90 degrees, and then we get to our loop, where if there's a server available, it will open up the website, or well, you can open up the website, and then you can slide some sliders around to position the arm. So let's see if we can get this to work, fingers crossed. Okay, and while it's compiling and uploading, we can have a look through what this code is doing. So I'll show you what this will look like on the website once it comes up. You should get a picture that looks like this, and these are the sliders. So initially they're all at 90 degrees. And what you can do is you can click the slider and move it, and then your robot arm reacts accordingly. So for example, if you slide the base servo in this direction, it rotates the turnstile in one direction. If you slide it in the other one, it slides the other way. The number here will change and the angle changes. So these are the 4 different servos, and that's what you will see on the computer screen when it comes up. So let's have a check again and see this one. See if it's working yet. It's still thinking about uploading. It can take quite a while, but we can keep talking about it. So these are the different sliders. If you click anything on the website, it then makes the slider look different, and it asks the servo to move. There's a lot of information here about the HTML page, which is provided to you. You can have a go at figuring out what all of this means if you want. If you use HTML, then this probably will be a little bit more intelligible to you. If you've never used HTML before, you probably just skip that. But here we are with the base angle, very similar to before. It looks to see what the number is between 0 and 4095, and then it maps that to between 0 and 180, which are the degrees, the angle of the servos. And it does that for each one of the servos. Okay, so this has come up now and said that it has the information. We missed the serial port where it gave us the IP, but I'm going to fingers crossed hope that it's the same one and that it works this time. So here it is. Now it's worked. Who knows what the difference was? So here we have what I was just explaining. We've got 90 degrees and it's in the middle. But if I were to move it over here, for example, that's now 26 degrees and my robot arm has just rotated to the left. If I switch it to 160, it's moved to the right. Here's a video of the web server controls and the robot arm over here. So, let's back up so you can see them both at the same time, I suppose. So, if I change the base servo to go to the left, we can see it rotates to the left. If we change it to go to the right, swerves to the right. Let's put it back in the middle so it's slightly easier to see. For the arm servo, that makes it go up in the air, or we can make it go down to the ground. The forearm servo, we can make it go down on the ground, or ideally, since it's already on the ground, up a bit. And then finally the gripper closes it here, or opens it there. And I can move the arm of the servo, the forearm of the servo, I can change the gripper. Okay, so you can do all of this interactively using the website if you want to. This was interesting to look at, in my opinion, but I much preferred using the joystick to, to fine-tune these directions and angles. And my favorite one was probably where you could save the 10 different locations and then circle back through them, because I could see the practical applications of that. This is nice to understand how the website works, when it works, but I thought was a bit fiddly. Also, I probably would have made some slight changes, like having this be in the middle for 90 degrees, because having it off to the side is a bit odd. But anyway, this is showing you what it would do. So hopefully you found this review of the code useful. It's longer than when I give you, a 2-minute overview of what I liked and didn't like. But if this code is new to you, then hopefully this has been useful. If you have any questions, you can put them down in the comments below, and I will do my best to try to answer them. Thank you.